Today's lesson is on special products. There are several types of multiplying binomials or polynomials that come up fairly frequently, and we're going to cover those specific cases and see if we can't make this process a little shorter. So remember that when you take a binomial a plus b and you square that binomial, that does not mean a squared plus b squared. A lot of students want to take that 2 and distribute the 2 to the a and the b like we did for monomials, but because there's a plus sign here, that doesn't work. You are not allowed to distribute the exponent over an addition sign. Okay? Let me show you why that doesn't work. Let's take 3 plus 5 quantity squared and 3 squared plus 5 squared. Let's see what that equals. If I take 3 plus 5, that gets me 8, and then 8 squared is 64. What if I took 3 squared, which is 9, and add that to 5 squared, which is 25? 9 plus 25 is 34. We can clearly see that the left 3 plus 5 quantity squared does not equal the right 3 squared plus 5 squared. It's just not true. But there is a way to square a binomial. So in order to square a binomial, we're going to use the definition of exponents. So I want you to write the parentheses multiplied by itself to indicate that binomial is being squared. Because what does squared mean? Multiply it by itself, right? Then I want you to distribute as any other binomial times binomial problem. Okay, so for example, like 4 squared means 4 times itself 4. 12 squared means 12 times 12. So if we just use the definition of a plus b squared and write it out, a plus b times itself a plus b, and then distribute just like normal. So we have a times a is a squared, a times b is ab. Then we have b times a, which I'm going to write ab just to keep it in alphabetical order. You could write ba, but I like having things the same so that I can clearly see that ab and ab are like terms. If you wrote ab and ba, some students have a hard time seeing that these are truly the same thing, but that's why if you just write it in alpha order, that reminds you that yes, they are the same thing. So I have one AB plus another AB, that adds up to 2 ABs. So we have a squared plus 2AB plus b squared. And that's how you're going to multiply binomials. So we have our first example, x plus y quantity squared. So instead of trying to distribute the 2 to both the x and the y, because that's not going to work, what we're going to do is we're going to write out our parentheses x plus y times the other parentheses x plus y, and double distribute. X times x is x squared, x times y is xy. Then come back and grab the y and distribute that as well. Plus xy plus y squared. Remember that the two middle terms are like terms. They both have a leading coefficient of 1. So they add up. I have x squared, 1xy plus another xy gets me 2xy plus y squared, and that is my final answer. Let's do it again, x minus y squared. That means x minus y times itself x minus y. Don't try to do this in your head, you're going to have to write it out. X times x is x squared. X times minus y. The negative times a positive is a negative. X times y is xy. Then I'm going to come back and get the negative y and distribute that as well. Negative times a positive is a negative again. Y times x. I'm going to put the x in front of the y just to keep things consistent. And then on the last one, negative y times negative y is positive y squared. Remember that there's a negative 1 in front of each of the xy terms, and when I add them up, we get negative 2xy. On our next problem, we have x minus 5 quantity squared. So I'm going to write that out. X minus 5 times itself x minus 5. And then double distribute. X times x is x squared. X times minus 5 is minus 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. Double distribute. The two middle terms are like terms and they can add up. Negative 5x minus 5x is negative 10x. You may be noticing that the two middle terms, every time we have a binomial squared, happen to be the exact same term. Like on the first example was 1xy plus 1xy. On the second example was negative 1xy, negative 1xy. On our third example it's negative 5x, negative 5x. And that is a pattern that it might help you to solve these a little bit faster. But if you're like on a test and you're just wanting to do it, you don't need to know the patterns. You just need to be able to write it twice and then double distribute. For our next problem, we have x plus 2 quantity squared. I write it out twice. X times x is x squared. X times 2 is 2x. Then I grab the plus 2 and distribute that as well. 2 times x is 2x. 2 times 2 is 4. And then we have the two middle terms, which are like terms. 2x plus 2x is 4x. And the first and the last terms, which don't have any like terms, just come down. On our next problem, we have coefficients in front of the x this time. But no big deal, it's all just done the same way. 2x plus 3 quantity squared means 2x minus 3 times 2x minus 3. And then I double distribute, just like I did before. 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. I'm going to come back and grab the negative 3 and distribute that as well. Negative 6x plus 9. So that's 4x squared. These two middle terms, minus 6 is minus 12x plus 9. And that's my final answer. Our last problem is 5x minus 4y quantity squared. So I'm going to write that twice and double distribute. 5x times 5x is 25x squared. 5x times minus 4y is negative 20xy. And then the negative 4y, I'm going to distribute that. The negative, make sure that that gets distributed with the negative 4y because the negative sign is always applied to whoever's behind it. So that gets you negative 20xy. Again, I like to keep it in alphabetical order, so it helps me realize who is like terms. Negative 4y times negative 4y is positive 16y squared. And the two middle terms add up to negative 40xy. Notice that the two middle terms never canceled out. They always added up because they were always the same sign. Alright, so now I just want you to notice that there have been a lot of patterns here. If you notice any of those patterns, you're welcome to use them to make you get the answers quicker. Some people may have noticed that the first term is always a square. 4 is a perfect square, 25 is a perfect square, x squared is a perfect square. Okay, that's one thing people might have noticed. Another thing people might have noticed is the last term, 25, 4, 9, 16y squared. Those are also perfect squares. Okay, so that might also help you get to your answers a little quicker. And then the other thing that you might have noticed is that the two middle terms were always adding up. And they were the same term, negative 6x, and they always added up, negative 12, every single time. Negative 20 and negative 20 added up to negative 40. So if you see patterns when you're doing these, that might help you so that you can maybe do a little bit less work and just get to the answer a little quicker. I'm going to leave that up to you, whether you just do it the long way like I just showed you how to do, or if you want to try to notice some patterns.